Okay, uh, let me start with this derivative. Okay, so let me start with the ln. Okay, as you know that if you have ln x, you will have this is just the 1 over x. Okay, so if you have ln and inside is the functions, okay, what you can do is uh, derive as ln, so 1 over, and put everything in the bottom, okay, and multiply with the derivative of the inside is the f of x, so f prime. So you can also write this, and it's become one characteristic for ln. Okay, so every time ln has a function inside, you can derive this. Okay, but the question is, if the function inside have more than one function, it's a composite, for example. So you need also to derive layer by layer. Okay, so for example, if you have like the f, g, or maybe triple f, g, h, then you need to uh, derive this layer by layer. Okay, and we already um, uh, discussed the chain rule and how we can make the functions as complicated as we want. Okay, so when you are dealing with a data set and you have more than one models and you want to combine them, and you know the relation between the two models of your functions, okay, later you can also combine them and have some observation in a composite functions. Okay. Yeah, it seems in calculus it's not really that much applications that you can think of. But when you are in the second year, in the third year, you learn about the a little bit programming, a little bit of coding. You need the basic of a little bit of calculus plus matrix if it's included coding, or if you're learning MATLAB in the future, you need to learn a little bit about the matrix, how to inverse the matrix, okay, and so on. Okay? But that's the another courses. Okay. So today, actually, I want to go to explain a little bit about the L'Hopital rule, because some of you are using L'Hopital rule in the exam. Although I write you cannot use L'Hopital rule, but some of you still use it. But some of you use it in the wrong way. So I need to explain it to you a little bit. But I think before that, let's check these two examples, and then we can move on to a L'Hopital rule. Okay. So I have two cases here. Okay. The first one is square root of x plus square root of y is equal 1. And the other one is y equal x with the power of x. Oh, let me move here and make bigger. Okay. And you need to find the first derivative of these two cases. Okay. You can do whichever method of derivative you know. Okay. At least more than one way to solve each number. Okay. There is more than one way, and based on how you are preferring your actions, that's up to you. Okay, which method you really prefer. Last time also we already discussed the implicit. You can use it also here, implicit differentiations. Let me give you 2 minutes to think and try. Number one, I prefer to use implicit because you can directly get the answer. But if you want to square and then make y equal something, that's also can be done. Okay. So for example, you can write this as 1 minus square root of x and squared, and you can derive as usual. It can be done also. Okay. So squaring both sides and try to simplify and solve the first derivative is also one way. Okay. The other way is just doing implicit differentiations. Okay. Number two also, I think I have two methods to solve number two. One way is just doing implicit. The other way, uh, rewrite the form, and make in log in ln. All right, check number one is okay, right? Okay. Okay. How about you? Yeah, you need to equaling this, so moving this part and y. Yeah, yeah. Yeah, this is correct. Actually, up until here is already correct, and you can change this to the all x, right? Yeah. How about you? Do you get it? Okay. I think if you don't get it, do you understand the concept of implicit differentiation like this day? How? How do you use L'Hopital? And what is L'Hopital? What is L'Hopital? No, no. L'Hopital is used when you are dealing with limit. That's okay. That's wrong concept. Okay, here. Let me give you a simple practice to this. So you have square root of x and square root of y. Okay. Implicit differentiation is derive all like usual, except in y you need to add something. Okay. For example, you have how to derive this. 2x plus just derive as x just 2, but you need to add multiply dy dx. Okay. Okay. So here you get 1 is the first derivative of squared, and it's also the same way here, but you need to add multiply with dy dx. Is that helpful? Okay. And dy dx is you can just solve it. Move it. Okay. You get it? Okay. Do you understand how to implicitly differentiate? No? Okay. Here. So if I have this, okay, how you differentiate this? Just treat as x, all x. Okay, but later I will make an exception for y. So x squared just become 2x, right? Plus 2y, it's just 2, like x. Okay, if you have 2x, it's 2, right? So 2, but in y, because it's implicit, we need to add the dy over dx. Do you get it? So every time you have y inside the some equations, after you differentiate, you need to multiply by its dy dx. Okay, okay? Get it? Yeah. Okay. You get it? Yeah, it's okay. Mm, but why it's become this? I think you have some mistake here. Okay. Yeah, good. Okay. It's okay. Yeah, good. Good. Okay. I think part number one is not too complicated. Okay. Um, if you are using implicit differentiations, so it's just let me write one by one for you. So we are d dx. So if you ever find any d dx in the front of the equation, meaning it's a tools, meaning the inside needs to be derived. Okay. So 1 become this. Okay. 1/2 square root of x for x, and y become y, but you need to multiply with dy dx. That's for the implicit. And this is just 0. We can solve and make dy dx equal something, and maybe change the y into x so that all the equation become xx. It's also okay. Or it's just if you just use y in the equation, that's also fine. Depends on the case. Okay. If the question needed to have like only one variable x, then you need to change y into x. Okay. But you can write first. Okay. Y is, you can write like this using the exponent. Okay. And then you can write this like this. Okay. And you can differentiate e, like e to the x. Okay. So and then you have x, ln x. Okay. This is just a product rule. Okay. Fg. So you have the f prime g plus g prime f, which is we get the 1 plus ln x. And this part is, you can turn back to the original equation, which is this x to the x. Okay. Or, okay, the other way, you can write y x and add ln in the front. Okay. And then it will be ln y. And then I will move to the front here. Okay. And then I will use this derive all, okay, using implicit differentiations. Okay. So using implicit differentiations, I will get this is 1 over y. But don't forget dy dx. Okay. And then this is just 1 plus ln x. Okay. And move the y to the right side. Y is just x to the x, right? So x to the x, 1 plus ln x. It's the same. Okay. So whichever method you are approaching or you are choosing, it should be approaching the same answer. Okay. It should be the same answers. Okay. So several ways to deal with the some equations. If you think the equations, usually if you see the equations, it's including y, the inside, okay, in the inside, then maybe implicit will be faster. But it's not all the cases. You need also to check whether the other way is faster or not. Okay, okay, any questions first? Or do you have any other method? Maybe you have additional method? For now, I think this two is already fine. Already defined, and you can choose which one you prefer. Okay, any questions? No? Online students, any questions? No? Okay, this part, the E part, okay. This E with the power of ln is powerful tools, okay, um, I'm suggesting you to remember the form. Okay? So whenever you have e to the ln, it's actually 1, right? It's actually, you can just skip it and it's just x to the x, right? But when you are changing to e to the ln, you can have a new perspective to solve some problems. Okay, it's quite useful. Okay, let's move to yeah. This is just from previous one. Yeah, this is also the same. Um, oh, let me go for the inverse. Okay, the inverse before we go to L'Hopital. So I'm not sure how many of you are able to or have learned before how to solve the tangent inverse or arc tangent. Okay. So first, before we are going to derive the tangent inverse, what is the tangent inverse? We need to we need to have a definition. Okay. What is tangent inverse? If you have tangent, the easy one is 45, right? It's what? 1, right? 1. Okay. So tangent inverse of 1 is 45 degree. Okay. Do you get it? What the tangent inverse means? Or we can just use the triangle. Wait. Okay. Let's just use the theta. Okay. So let's imagine our angle in this triangle is theta. Okay. And then let's just make from our tangent inverse. Okay. So if the tangent inverse is some theta, okay, then my tangent theta is x, right? Okay. So if I'm applying in the triangle, it will be x and 1, right? And the hypotenuse will be x squared minus 1, okay? Like this, okay? Usually, I always forget how the tangent inverse or sine inverse or cosine inverse to become, how to derive them, to derive all of those, okay? So, wait, plus, okay. Okay, I know I'm smiling, and then I realize, oh, wait, okay. Um, it's better to it's okay to memorize all the formula. That's good. But sometimes, um, if you forget, then draw this triangle and you can solve many inverse trigonometric problems. Okay. So what is the derivative of tangent inverse? So I already changed this form into this one, right? Into the tangent theta is x. Okay. So I can maybe let me draw. Let's just derive all this. Okay. Tangent theta is what? Derivative of tangent theta is secant squared, right? If you forget, you can also derive that on your own. Sometimes we can forget, right? Especially in the exam. If you forget, remember you can always have this sine cosine, okay? And you can have the if this is f and g, then you can have the quotient rule, okay? Which is the in case you are forgetting how to derive, you will get secant squared for the sine over cos. So here is the secant squared theta, but because it's x and it means it's implicit. So we need to add d theta dx. Okay. So meaning the first derivative, what we need to find is d theta over dx. because in this case, I'm using the theta instead of y. Okay? And it is equal 1. Okay? And then d theta dx is 1 over secant squared theta. But it's in theta, right? So we go back to our triangle. Okay? Um, secant theta is 1 over cos, right? Cos theta from here is what? 1 over. So 1 over secant squared is cos squared, right? Or I will write this is become cos squared theta. Okay. And then I will write this as this whole thing squared. So it's become 1 over x squared. Okay. If you think it's easy to memorize, you can also memorize if you want. But don't forget, if you, in case, make mistake and you forgetting how to get this expression, go to the triangle. Okay. Go to triangle, define the theta, define the x, and use relations on all of them, and derive the d theta over dx. Okay. Okay. Any questions? Any questions? Uh, yeah, you can do the same thing with cosine inverse, sine inverse. Okay. The different will be the triangle. The x will be different. Okay. And just move the x and pretty much do the same thing, and you will get the answer for sine inverse and cos inverse. Is the triangle helpful? It's helpful, right? Okay. Because before I also tried to memorize like in my undergraduate, but it seems it's not working. So I decided to just use this triangle. Yeah. Hmm? Secant. 1 over cos. Yeah, 1 over cos. Secant. Okay. Okay. So sine, cosine, tangent, secant, cosecant, uh, cotangent. Do you know why the name is cosine? Co is complementary sign. So you see the sine and cosine is complement each other. Okay. If you have like co in the front, it's complementary. Yeah, I just knew it like when I teach. Before I also don't know why the name is cosine. I just read, oh, cosine is, oh, in this side and this side. Okay. But it's actually complementary, so you can see from the graphs. Uh, do you want to try the sine inverse? Okay, with the same method. Oh, good, 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 clever. Okay, okay. Yeah, you need to maybe draw the triangle, maybe. Okay, though. So firstly, you can define the sine inverse. Okay. So if your sine inverse is some angle, so your sine theta is just x. Okay, and maybe draw the triangle to help you solve. So sine is x 1, and this is 1 minus x squared. Oh, this is different. Okay, and then derive from here. First derivative is cos theta d theta dx and 1. And d theta dx is 1 over cos theta. So from here, cos theta is, so 1 over cos theta become 1 over square root of 1. Okay. And the typical questions in solving the inverse, okay, inverse for trigonometry, sometimes the question is looks like this, okay, cos, and then the inside is sine inverse x, or sine, maybe tangent inverse. To solve this, you need to combine, okay, you need to combine, okay, chain rule plus the inverse trigonometric, okay. So it's like, for example, for cos, okay, you know the cosine derivative is minus sine, right? So if this is y, then y prime will be negative sine, okay, of all of this multiplied with the d dx of, and then you need to find the sine inverse, okay, and you need also to define the sine inverse. If you define this as theta, then this becomes sine theta. Okay, and sine theta you can get from also from the triangle. Okay, you can also draw a triangle here. Get the idea? Okay, so I hope you get the idea. Okay. And then after that, you just multiply with this. Yeah, maybe later in PA session, you will get more practice. And maybe if I have uh, uh, review time next week, I will maybe give you one or two more examples. Okay. Okay. Any questions first? Any questions? Is it too fast? Too fast? Or so? Okay. Okay. Too fast from the behind? Too fast? Too fast? Okay. Which one you still confused with? This one? Yeah, this is just illustration. I didn't solve it. Okay. But this is the middle way. Okay. So it's like the chain rule. So you have functions. This is functions. This is functions. It's function inside function. Okay. Like a regular chain rule. So you are making this as our chain rule. So this whole functions, the outside functions, you derive this. The cosine become negative sign. With you can have anything here, right? You can change this into under function. But in this case, this is the function. So we write this as our function. And we need to multiply with the inside functions, okay, which is the sine inverse ddx. We need to find this. I think we already find this, change this, and negative sine theta, we need to just look at our triangle, which one is our sine theta, and change all to here, and then multiply, and that's your answer. Okay. If you want, you can try by your own. Okay, and try also the sine tangent inverse. And if you maybe you want to practice, you can also have another way, like tangent and then maybe cos inverse. Yeah. Okay. Maybe I will make this in your another quiz. Maybe. Okay, the next one. I will go through the L'Hopital rule first. Okay, the L'Hopital rule. Yeah, let me go to the next slide. And let me write this is the L'Hopital rule. Actually, L'Hopital rule in the textbook, it should be in the chapter 4. Should be chapter 4, but I will move here instead. Okay, because I think it's easier if you still have the concept of limit. Okay. So L'Hopital rule, the practice or how to use it is quite easy. Okay. So if you have the, let me write the, if you have the f and g, both are differentiable and continuous. This is 1, and then 2. If you have number a, it should be equal with the g, which is 0. And 3, actually you can also have the infinity, but infinity needs to work out because 1 over 0 is infinity, okay? Or 1 over infinity is 0. It's switchable, so I just write 0 in this case. Okay, I will tell you later what does it mean. Okay, and if you have limit approaching the a, okay, of fx over gx. Okay, this is the L'Hopital rule. Okay, sometimes you are writing LH L'Hopital, meaning you are using the L'Hopital rule. You derive the top one and then bottom one. Okay. Okay. How to prove it? Okay. I will write some equations, but it is just rough proving. Okay. Uh, okay. So based on our definitions, let me write this gx. Based on our definitions, okay, this part, okay, fa and ga. In our definition here, our assumption this is 0. Okay, so I can add plus or minus with 0. It's still the same, right? So I can make this fa, and then this is ga because both are 0. Okay, just add them, subtract them, and this become limit x to the a, and then I will make this become, I will multiply with 1 over x minus a, both the top and bottom. So it will be this x minus a, and this is also x minus a. Okay. And from the definition of limit, we know that these two are derivative of f and derivative of g, right? So roughly, we can say that based on derivative by limit definition, this whole limit is our f prime a and g prime a. Okay. Okay. Mm, okay. Let me show you another way to see the L'Hopital rule. Okay. Uh, do you want to write it, or yeah? We just put the next page first. Okay. And uh, not just have functions. Okay. So if I have these two functions and I have the questions is f over g, when you plug in 1, it's 0, right? Both functions become 0, and it's 0 over 0 situations, which is applicable for L'Hopital rule. You can do L'Hopital rule here, but let me draw some graph. This, you can factorize this to what, 4 and 1, right? Yeah. So I have minus 4 here and 1 here. to be -3 over 2, which is in here. Okay, let me just draw like this. Quite so bad. Okay. And then the ln maybe like that. Should be lower, but yeah. What I just want to show you is, okay, the blue one is the fx, okay, and the red one is the gx, the ln. Okay. So you see that the both functions with both functions having a curve, right? But you can observe, like make some zooming, okay? And imagine when you zoom and using the website graphing calculator, and then you try to zoom in some point here, okay? Because when both are x equal 1, if both are 0, right here, both are 0 here, both are 0 in that point, okay? Nearby that point, okay, nearby that point, let's say this is dg, because it's g, okay? Why so bold? Maybe I will dg, this is dx, okay? And then I have also here the blue one here. This is df and dx. Okay. We can observe this when we observe like closely, zoom, zoom, and zoom. It's like a straight line. Okay? It's like straight line. Like you remember the tangent, the gradient. At the curve, it's like the straight line, like a linear. Okay. So I can rewrite my ratio, okay, ratio of my functions, okay, based on the tangent, our gradient, is df over dx and dg over dx, okay, which is practically, it's the same as what we think of the derivative of f and derivative of g, okay. So you can also trying to having proving, okay, not really proving, but make sure that you understand the concept by looking at the graph. Okay? So when you are zooming this part, zoom, 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 okay, I see a straight line. So how about I'm using the definition of derivative, which is the gradient, which is the tangent. Okay, so the tangent of this triangle is perfectly the dg over dx and df over dx, right? So every time it's moving, the ratio will be the same, right? So it's the same as our first derivative of the f and first derivative of g. Okay, so you can also proving by looking at the graphs and zooming some points. Okay, but it's not exactly some point because derivative is by limit definitions. It's close by that point, so you can see closely, like maybe 0.00 something near that point. Okay? You can see the straight line. Okay. And that's also the same way to approximate any point with some straight line. Okay. Um, that's useful for many methods in computations. Okay, okay, that's the some proving, and I have some picture later, but before we go to another graphs that I already prepared here, uh, let me remind you about the identity, okay, for the L'Hopital rule. Okay, so we call this is the indeterminate forms. Okay, so whenever you see 0 over 0, infinity over infinity, we call those terms indeterminate. Also, like number 2, I think this is also, I'm not sure this class or the other class. You're writing the 0 and infinity. this is called indeterminate form, which is we cannot really define what it is, except we try to solve it through maybe L'Hopital rule or another method. Okay, so this is called indeterminate form. It's we cannot determine yet what is it. Okay, and also the other form is 0 with the power of 0, 1 with the power of infinity. Yeah, it's strange, right? It seems 1 is always 1, but it's still called indeterminate forms. Okay, and then the infinity with 0. Okay, why it's called indeterminate form? Because when we approach this all of this with limit, we need to have another method to simplify our way. Okay, if we just limit and we have this forms, we can conclude at that time, okay, this is indeterminate form, so I need to think another way. Okay, so the idea of indeterminate forms, okay, just keep in mind all of your L'Hopital, okay, based on our proving in the previous slides, is only this case, 0 over 0. So whenever you have infinity over infinity, which means you need to have 1 over infinity becomes 0, right? 1 over infinity becomes 0, 0. Okay, so that's the case. So if you have this, uh, both of this is 0, this is infinity, both are able to be in L'Hopital because infinity is switchable between the 0. So you can derive both, okay? Directly derive. So number 1, it's fine. You can directly derive the f and g, okay? The top one and bottom one, derive 1, 1, okay? And you solve it. But you can do as many as you can. Okay, if you do L'Hopital rule and you still have 0 over 0, you can do one more until you get the final form, which is when you plug in the number, it has a value, and that's it. Okay, so you can have L'Hopital, L'Hopital, L'Hopital as many as you can. Okay, as long as it is still 0 over 0, you can L'Hopital as many as you can. Okay, okay, number 2, this form, if you have this one, okay, so x ln x. Okay, so to give you an idea, something 0 multiplied by something infinity. How we define that? Maybe our thinking saying that, oh, any number multiplied by 0 is 0, right? But remember, okay, this is also another point. Okay, infinity is not a number. That's the first case. Infinity is an idea. It's abstract. We cannot really know what the number of infinity. Okay, so that's why when you have the domain and range is all in real number, you write this as in open. Okay, not this. This is wrong. Okay, if in a closed bracket, meaning you are making the number of infinity as real, but it's not real, right? It's an idea. It's abstract. Okay, so you need to write open bracket infinity. Okay, so when you have 0 and infinity, the graph or the idea is not sure whether the function is getting 0 first or getting infinity first, right? So that's why it's called indeterminate form. Okay, so in this case, what are you going to do? We can rewrite the form. Okay, we write the fractions and force these two functions become 0 over 0 or infinite over infinite. That's when you can derive and use the L'Hopital rule. Okay. Also, this case, okay, 1 over x, 1 over sine x, approaching to 0, 0, and sine x is also 0, and it's become Infinity minus infinity. Oh, it's 0. It's no. We cannot minus this, okay? Again, because this is an idea, it's not a number, okay? So we cannot do that. So it's also indeterminate form. So how we are going to do? Make x sine x multiply, make this form, rewrite this form, and check it. Okay, it's 0/0. So you can L'Hopital this function. You can use L'Hopital rule from this. Okay. Also, what else? Oh, here 0, 0, and 1 infinity, infinity 0. Also the same case. So the idea is how we can rewrite the form and make like a number one case, 0/0 or infinite over infinite. All of this is called indeterminate forms. Okay. So the idea, if you have the x to the x 0/0, 0 with the 0 power, remember the e. Okay, we can use the e. Okay? That's why it's also useful here. So we can rewrite the e. So when you rewrite the e, it's become this situation. So first it's the 0 with the power of 0. You make the e using the e, rewrite the form, and you have the x ln x, which is the 0 and negative infinity, which is the previous case before. Okay, and this case we can flip the 1/x to the bottom here, and it's become infinite over infinity, and we can solve this off. Okay. So how to solve this? It's practically the same thing as e, and then limit x to, and then L'Hopital. Okay, and then L'Hopital, and then that's the answer. Okay, L'Hopital rule, just one day, right? Finished. Okay, I think that's all for L'Hopital. Okay, so pretty much it's useful when you are dealing with limit, especially when you see. But first, you need to make sure it's 0/0. Okay, 0/0, and you can use L'Hopital. Sometimes it's faster, sometimes it's not. It depends on the case. Sometimes you just maybe factorize and then canceling the form, and you get the answer. Sometimes you need to just derive, and maybe it's faster. Then you can use L'Hopital. Okay. Okay. Online students, do you get it, or do you have any questions? Or is it too fast for you? Okay, so we have three forms. Okay. The first one is 0/0 or infinite over infinite. This one is important. So every number 2 and number 3 form, you need to rewrite and making the 0/0 and infinite over infinite. Okay. Do you need to zoom in? Yes, Dirk. Why we can switch the limit of e to the limit of ln x over 1 over x? It's the limit law. Okay. So when you have the something with the power of actually the variable that you are um, observing, then you can switch the limit to the x. just the index. That's possible. Like when you have the ln, you can go inside the ln. Okay. One more thing about the L'Hopital. This is just showing you the graphs. Okay. Okay. So this one is the y equal, or the function. This is the functions. Okay. Sine pi x over x squared minus 1. Okay. The blue one here. So when you are approaching this x to some number, some x is approaching 1. As x approaching 1, what is the value of these functions? So if we draw the graphs, okay, and we put point A here, the x equal 1, okay, it will reaching some point, okay, around this B, okay. But when we plug in the number, this is 0 over 0. So if you draw, actually you can see what the limit is, okay. And when you are trying to separate the functions, become tree like this, okay. So the red one is the x squared minus 1. The green one is the sine pi x. When both are equaling 1, they both are 0. And they have here actually if they are combined. Okay. So you can also think of like a triangle in this area for the red one and the triangle for the green one here. And it's the same in like I mentioned before. When you have a gradient near that point, you will treat them as a linear, like a triangle. Okay, so you can have a tangent, and when you are dealing with the ratio, it should be the same, the ratio when they are moving, and they will reach the number b. Okay. Okay, I think we can have another sections today. Let me move to related rates. Okay, related rates. And we still have, if you still have difficulty or confusion, we can have some discussion next Tuesday. But now you are already know the implicit chain rule, implicit, the L'Hopital rule, and also now I will show you the inverse, also the inverse trigonometry. And the next one will be the we call it the related rates. Okay. Oh wait, there is a question, Pitasha. How about 0 multiplied by sine infinite is it the indeterminate forms? Yes, it's indeterminate. Okay. Okay, related rates. Okay. So remember the one I show you, the you have a wall and you have a ladder, and the ladder is slipping down. Okay, and you need to if you know this dy dt is known, and it's asking dx dt. Okay. So this is one of the problem in related rates actually. I will write how to solve some of the question in related rates. So the idea of related rates is there will be some cases. So I think it's better if you read those cases because it's like a story, like a story. So like it's like one paragraph is telling you something, maybe going somewhere with some velocity, blah blah blah, and then you need to uh, calculate other velocity with, so for example, if you have like I'm going here and someone going and passing by, and you need to relate if both have velocity and how we can relate those two velocity each other. One way is through the, if you imagine I'm going here and you're going here, then I have, at some point, I make a triangle, right? And we can use this one as our observations, this hypotenuse. So when I go here, you go here, and this hypotenuse also have velocity, right? It will be also decreasing as we meet each other. That's also one way to solve it. So the idea is you need to compute, okay? Compute the rate of change, okay? It can be anything, like when you uh, like blowing the balloon and it's getting bigger. You can also think like a volume change, or maybe um, if you have like a coin, it's heated and it's become larger. That's also a case. You can um, calculate the how is it how the rate of change of the coin. Okay. So first, you compute a rate of change. Let me write off one quality in terms of rate of change of sorry, it's not quality, it's quantity. Another quantity. So what's the deal? Okay. So first you need to find. Let me write here. So first, okay, you need to find the relations. Find the relations or equation or formula. It can be like I'm showing you. We can use the triangle and the Pythagorean. We can use area, volume, any. I think there will be not too complicated. So usually it's just a simple equation, okay, for the relations, and then including the chain rule. So because we are dealing with rate of change, so we are dealing with terms of time. So we add dt, okay, like in physics also. You have positions in terms t, derive, and you will have d dt, okay, all in all terms. I will show you how we are going to do it. So the third part is differentiate both sides. In all cases, in all problems, these three are mostly you are doing. Okay? So you need to find the relations, find it is the chain rule. You need to include the dt, and then differentiate both sides. And when you differentiate, sometimes it's like implicit, okay? But you are having a dt. I will show you how to deal with it. Oh, because I haven't write it, so maybe I will write it down for you. Okay. So let's go for maybe one or two examples. Let me write write the question for you. Okay. So car A, okay, is traveling west 50. This is miles, okay, miles per hour. Car B is traveling north. This is 60 miles per hour, and both headed for intersection of two roads. And the question is, at what rate are the cars approaching each other? Or let me write the information for you. When car A is miles and car B is miles, okay, from the intersection. Yeah, this is example of related rates. Okay, so you have a problem. Okay, you have a car A, car B, both are traveling. Okay. A is traveling west. It wins with some velocity. B is traveling north, and both will meet at the intersection. And the question is asking, at what rate are the cars approaching each other? So see if you understand the logic of the question. The online students, you can also try to think of this question. Actually, one example is the ladder. Like I already told you before, that's one example of the related rates. Okay. This is also another problem. So the usual case is ladder, someone moving, two person moving or two object moving, um, area increasing. Okay, it can be triangle, circle, any area that can you think of. Okay. So first, before you are trying to answering these questions, my suggestions is draw the some draw the event. Okay, you have traveling west, maybe drawing some car here, go here, maybe car B going here to north. Okay, so the question is asking when car B and car A is in some miles from the intersection. So you can have this triangle here, right? Okay. So let me draw for you. So it's this car going here. It's A, and B is going here. This is the event that's happening, and it will be crossing each other. They will meet in the intersection here. Okay? And the question also mentioned that when car A is 0.3 miles from the intersection. So this is 0.3 here. And car B is from maybe here. It's 0.4. So when B is here and A is here, at what rate are the cars approaching each other? So of course, if you are thinking as B, you will see A is driving with some velocity. If you're thinking as A, you are thinking B is driving with some velocity because you're also moving, right? Yeah, in physics, it's like relativity, right? So you need to have some points that you can make sure that you can see both of them, right? When you are here, you can see both of them, right? And when you are dealing with these two, okay, see what's happening, okay? So I will write A is changing, B is changing, okay? So what is also changing in between A and B is the distance, okay? Is the distance between this, okay? This distance is also changing, okay? So all A, B, and maybe you can call this C, okay? This C also changing, okay? So C also changing, okay? So we can make some, or we can think this as like a triangle, okay? Like a triangle. So for triangle, I think it's best if you're just using this as your relations, okay? So as A is changing, B is changing in length, C also changing, okay? And if you are thinking of the Pythagorean, we can include this in our calculations, okay? So we are including the C as our rate of change for uh, to see whether we can solve when A is 0.3 and B is 0.4. Okay. So let me move this drawing. Okay. So I have this Pythagorean. Okay. Let me write at A is 0.3, B 0.4. It's because it's 3, 4, 5. So you can now see the length of C is 0.5. Okay. So this is 0.5. But we need to know the rate. Right? So how to know the rate? So any relations you have, okay, you need to derive with respect of time. But we always see the related rates because it's rates, so it's related to t, the time. Okay, so we derive all these terms with t. So it's become 2a dA dt. Okay, this is the terms, and 2b dB dt, and then equal 2c dc dt. Okay. So A, B, C, we already know from here, A, B, C, right? Okay. And dA, dB is from our information. And we only need to know the C. And that is uh, one idea to see how these two are moving, the C, from the C, okay? So when you're thinking this triangle, the first one at the initial point is triangle is big, right? When it's moving, it's become smaller, okay? So you can think of the rate is in this case, because it's going smaller, in terms of the length. So I will write the velocity in minus. Okay, is that make sense? Okay, does that make sense? So positive or negative, it depends on how you are using your equations. Okay. Uh, so I will write this as 2 and then 0.3 and then negative 50 plus 2, 0.4. This is negative 60 and then 2 and then 0.5 and then this is dc dt. And this is becoming this is 1, so dc dt is equal negative 30 and 4 to 8 6 48. So this is negative 68 miles per hour. So negative or positive in velocity terms, it means its direction. Okay, so it means uh, you can also use the positive, but you need to understand what happens in the real time. I'm using the negative because I'm thinking, oh, it's going smaller. It's decreasing the length. Okay, so this minus means the c is getting smaller. Okay, in 78 miles per hour. You can also use the positive one. In exam, it doesn't matter as long as you're consistently using that and you understand what does it mean. Okay, positive, negative, it's okay for me. Okay, because I'm thinking the negative is because the length first is you having this and then it's getting smaller. You're getting decreasing in length, but you can think of like a positive just like in velocity. Because both cases are the same value, 78. Okay, any questions? Any questions? Related rates is, yeah, it's confusing. First, you need to understand the questions. You need to imagine the what is happening. Okay, what is the events look like? Okay, and how to deal with it. Okay, whenever you have the relations in all problems related rates, what you need to do is just derive this to t. That's all. The difficult part is to understand to get this from the event, which formula you want to use. But usually the formula is simple and not too complicated. Maybe it's area of triangle, area of circle, maybe like this triangle, Pythagorean. Yeah, just like that simple formula, geometry, okay, like that. And then you derive this and look for the information, which one you are already have, and just plug in. And you need to just answering the other terms, okay, looking for the C. Okay. So let me give you one more example, okay, one more example or two if you have time. So number two, when a circular plate, I will give you the simple one first, okay. Increases Yeah, uh, this is actually easier than before. Okay, so you have a plate. It's a circle. Okay, um, you put in oven. I don't know why, but just that's the case. Okay? Just put in the oven, and then the radius increasing. Uh, do not ever think any abnormality in related rates, because if you think of that, you can solve the question. So think simply, if it is larger, and you think larger uniformly. Okay, so it will be not any defect or anything that abnormal. Okay, so think just increasing the area uniformly. Okay, you have the rate of the radius. So the radius will increase at that rate, and you have the question is the at what rate is the plate area. So the question is asking the area. Okay? Area. So you have the radius, and this is asking the area. So you have area and radius, and you have circle. I think you know the area of circle, and just use that, derive, and plug in the information, and that's it. So it's asking the plate's area, the rate of change of plate's area. Okay. You know the rate of change of the radius. It's asking the rate of change of the area. Okay. Yeah, just multiply, and then yeah, that's it. Yeah. Okay. So you have a circular plate like that, and you have the radius. So you are it's increasing, right? Increasing. Okay. First, you know the dr over dt. It's the rate of change of the radius. Okay. You know from the question is 0.02. Okay. And because it's asking the area of the circle, we write first the area of circle. Okay. And then, like I said before, any equation you have, derive those equations. Okay, just derive with terms of t. So you have dA dt is 2 dr dt. And because it's just asking the area, so it means the dA over dt. Okay. So dA over dt is 2 pi 60 when the radius is 60, right? When the radius is 60. And dr dt is 0.02. So 2 over 100 to 60 is 120 to 4, 2.4. Is that correct? Yeah. And then maybe check the, is it in meter or centimeter? Square. Okay, let me give you one more and see if you can solve it or not. Uh, it's also simple, but more difficult than this one. So two sides of triangle. I will write this is not necessary, not necessary. Right triangle. So two sides of triangle are 5 meter and 8 meter in length. And the angle between is increasing at the rate of 0 0.0, let me write it in blue. This is also blue. The question is find the rate at which the area of triangle is increasing when the angle between, well, it's long, between the sides of fixed length is pi over 3 radian. Okay, two sides of triangle. It's not necessarily right triangle, meaning it's not the 90-degree triangle. Okay, so it is random triangle. Okay, so the two sides is 5 and 8 in length. So the angle between is increasing. So you have a, let's say, just theta at the sides of the angle. So the angle it's increasing. Okay, so you need to find the rate at which the area of triangle is increasing. So it's asking the relation of the two sides with the area of the triangle. So when you have two sides and it's increasing in angle, the area is also increasing, right? The question is asking what's the rate of change of that area, the area of triangle. At least you know you need to write down the equation for triangle, for the area of triangle. But because it's not right triangle, you need to think another area when you are calculating the triangle. It's half. Yeah, 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 yeah. Good. Yeah. Okay, it seems a long question, but actually it's not. Uh, the answer is quite short. Okay. Do you get it? Which equation you are using? Okay. Okay. You get it? Yeah, you can just plug in here the theta. Yeah, I think it's okay. It's good. How about you? Okay. Y is square root of 3? 60? Check. Confused? Okay. Hmm? What is sine 30? Sine 30? I always remember sine 30 is half. So the cos 60 will be also the same half. Right? Right. This is only the mistake you have. The square of 3. Okay. Let me explain to you. Okay, so two sides of triangle. Okay, let me draw the two sides of triangle. So maybe that, okay. And maybe theta here. Uh, it's smaller. Okay, so it's 5 meter. It's 8 meter. Okay. Let me remind you. Maybe some of you still don't remember how to solve the area of triangle. Usually just base and height, right? Usually just this. Okay, but because we don't know our height, okay, so we need to have the theta here, which is since sine theta is h over a, and h is a sine theta. Okay, so our area will be, in case you are forgetting how to get the area, okay, the area of triangle is half a b and then sine theta. Why it's a? It's theta. It's bad. Okay, so you get this one, and then just derive of this. Let me just write as a is half 5 8 sine theta. Let me just make this as 20 sine theta. Okay, and this derived to dt is become dA dt, which is our questions. It's this the 20 cosine theta and d theta dt. Don't forget the d theta dt. And then the question is asking when theta is pi over 3. Okay. And dt over d theta is 0.06. So dA over dt will be 20. Cos 60 is half, right? And then 0.06. So it's just that. Remember to write this, okay? Okay. So every time you get the relations, I think in all cases, most of related rates, you just need to derive those equations. Okay? If it is asking the area, then you need to find which kind of area. You find the relations, derive. Okay. If it is like the Pythagorean, then find the relations and derive. Okay, that's just three examples. I think this is the simple one. Um, Maybe tomorrow your TA will give you some related rates, but maybe more general and implicit for tomorrow. Maybe okay. There may be one or two related rates. I will maybe giving you more one or two like not as simple as this one. Okay, but maybe to help, you can check the PDF files for the chapter derivatives. I forget which section. It's 2.5 or 2.6. I forget. Check the questions. Okay. Check the words and how you understand the questions. Okay. Because sometimes the question using some terms that we don't really use often, like maybe you don't hear often in English. Sometimes the questions. Okay. So you need to read first. Okay. But if I make the quiz or exam, okay, I will make sure that all the terms are the most like usually people use. Okay, if there's like terms that you don't really understand and you will have a confusion about the questions, I will guide you in the quiz, or maybe giving you some picture to give you the idea of what kind of questions it really is. Okay, because to understand related traits, you need to understand the questions, okay, the language. Even when you read the exercise, because it's in English, so you need to understand that. Okay, okay. I think I will stop here, and we will continue next Tuesday. So I will continue maybe a little bit related traits and about the some exponent, just a quick review, and linearization, and that will be finishing our chapter 3, right? Chapter 3. Okay, that's all. Okay, online students, any questions? I think we can finish now.